ओके। कैसे हो भाई? ठीक है भाई, करते हैं लास्ट क्वेश्चन सॉल्व, फोर्थ क्वेश्चन। भाई ये तो डिफिकल्ट क्वेश्चन है। ये 3-4 घंटे लग गए भाई मेरे को सॉल्व करने। इट टुक मी अराउंड 3-4 आवर्स। तो देखते हैं, चलो लेट्स सी हाउ आई हैव डन इट। सो बेसिकली अपने को nums array given है, वी हैव गिवन a nums array, right? And we have to return the maximum possible sum of subarray of nums, that is a palindrome. So if you know the algorithm, Manchar's algorithm, right? It's pretty easy. You can do it, but मतलब नहीं पता होता भाई. I don't know this algorithm. It basically finds palindrome in often, but I don't know this algorithm, and see, normal people don't know this algorithm until you do like heavy competitive programming. This people don't know this algorithm. Okay, so then what I did, so I initially found the right a matrix, basically let's say DP, where L comma R denotes, right, this L comma R. So any, let's say this is Lth column and this is rth, right, rth column Lth row. If it's true, it means it's a palindrome, right? Then this takes, right, n cross n space complexity, and time complexity is also n cross n. So you get both MLE plus TLE. But it will definitely solve the equation. That's a brute force approach. So you will get MLE plus TLA since n less than equals to 1 e raised to power 5. So we cannot do this approach. Now, the next thing I thought is the main problem that Naila have done is finding the palindrome. Basically, effectively finding the palindrome. This is the main problem. Then second is finding subarray. This we can done in O of 1 by calculating a prefix sum. Easy. Okay. So now, okay, right, the next step what we are solving is this one. We have to find the palindrome efficiently. Palindrome we need to find. So what is a palindrome, right? From forward or backward equal, right? So let's say I will have x2, x3 till xk, right? Then whatever I have in this side, same will be on that side. If, right, let's say odd length, then this is xk, right? For even length, what it will be? x1, x2, xk minus 1, k minus 1 till 2x1. This is odd length, odd and even length both. We know this thing, right? Now we have given nums of I greater than equals to 1. What does it mean basically? This means this is very important actually. You see, if I have a subarray, right, let's say 10, 1, 2, 4, right, 2, 1, 10. Then see this thing, right? Let's say I am at index 4. This is my left string and this is my right string. Okay. See, how many palindromes I have? 4. I have 2, 4, 2. The next is I have 1, 2, 4, 2, 1. You see one thing, right? This is L comma R will be for this position, what it will be. This 3 comma 3, 0 based indexing we are taking. This is 2 comma 5. What is this? 1 comma 7. You think this is the sum will be 4, sum will be 8, sum will be 8 plus something. And now, since nums of I, right, all greater than equals to I, so I can say, right, if there's index, right, this L1 less than L less than R greater than R1, then I can say, right, sum of L1 comma R1 definitely greater than to sum of L comma R, right? Is this true? Right? True. This is definitely. So, are you here with me till now? This is very important. We need to understand this condition basically. So, once we understand this question, understand this particular right, uh, let's say once we understand this particular equation, then we can know, right? If I'm at an index, if I go in this side, some will increase. If I go in this side, some will increase. From any index in left and right, sums are monotonic, right? You can say some are monotonic. What does it mean? If sums are increasing, what I can do here? Binary search. Best. So now we have boiled down the problem to what? We initially have right. Now we are at the binary search. Now, so let's say I have this one, right? I am at an index that is 4. 2, 1. Next is 2, 1. I'll take this above example. And the next one is 10, 10. For this, let's say 10, 9. So now this side sum will increase, and in this side sum will increase. Okay. So now the question arises, how to check, right? If left string equals to right string, right? So if we brute force will be what? Match index, then time complexity will be what? N cross n. This will not work. Okay. The efficient is everyone learned this, right? Rabin-Karp algorithm. What it does basically, match pattern using rolling hash, right? So if I say, right, the hash function of this string, right, 1 comma 2, will this equals to hash string of this one, right? Will the hash of 1 comma 2, will it equals to hash of 1 comma 2? Yes, right? So okay, so now I reach to the conclusion of one binary search at each index, right? Second, for what? For max length palindrome. See, we only care about the maximum length, right? Since some are always, right, nums of I is always greater than equals to 1, right? So some will always increase as the length of the subarray will expand, right? So let's say, right, as the subarray will increase, right, sum of this one, the sum will always increase. Okay, next, right, for each index, what I want to check, right, the hash of what? Let's say this is my mid position. Here I will have some F, here I will so hash of this one plus hash of this one. So I say head of L comma mid. I need to check if it's equals to what? Hash of what? R to mid. Now it depends, right? If we consider this, now think about this one. If it is odd, right? Then mid will be only a single element, right? This will like 1 2 1. This only come once, right? So we can effectively match just 1 and 1 basically. If it's even, then it will be like 1 2 2. So if we say this is I, then we have to match what? L comma, right? This is I, right? And what will be this position? So some right comma I plus 1. This basically. So this is what we have to match. Okay. So are you here with me till now? So now we are tried first binary search at each index. Two scenarios, right? For odd length for even length, right? Right, odd length, even length. And what we have to do for each, right? We have to match has. We have to match has. So if yes, we increase our low to right mid plus 1. If no, we decrease our mid to mid minus 1. And whatever the best length, right? The best length we get, we add it to the sum to the answer. Okay. So we do right answer equals to what? Maximum of answer comma right? Sum of what? Let's say I'm at index, right? Whatever the half, so I say mid best length, right? So right, it's prefix sum. So best length plus right plus 1 minus sum of what? Index minus best length. So this is what we have done. Now the next question is, we don't want to calculate this has every time, so we'll pre-compute has, right? Pre-compute has. And what is a has function? So I have attached the diagram in my LeetCode solution, but let me explain. Let's say we have 1, 2, 3, right? Has function is, and right, we denote each index, right? So let's say from 1 to 2, right? 1 to 2, each substring will be a mathematical value. Each substring will be a mathematical value. Since we don't want the two values to be equal, right? So first we have to choose a p, right? The base. This will be our base. So you can say it anything px. So base should be large. Large. Generally like 31 works, so I prefer only, I just remember it's 31. So you just take 31, or you can do any longer number. Any larger number. It's less than modulo. Less than modulo. Okay. So see, for this 1, 2, 3, if my p equals to 31, right? For this 0th index, what will be my, let's say s will be 1. For this 2, what it will be, right? I say the previous one multiply 31 plus 2. This is my has function. Okay, so what will be for this one? The previous, right? Previous multiply my base plus what? The current value. So what do we say? Has, right? So hash of I equals to what? I say hash of what? I minus 1 multiply p, just take modulo operator here, plus add the current value, right? Again take the modulo operator here. So this is a simple way to calculate the hash. It's very simple. Okay. Now, since we need the string to match, right? Once in forward, once in backward. So we calculate two hash here. First is, let's say, hash prefix forward string, and the second, let's say, back. What do we say? It's backward. Okay. Once we have this one, right? Then to get a hash of any range, right? Hash of L comma R. What do we have to do? We have to do, right? Hash of what? R plus 1 minus what? Hash of L multiply what? Power of what? It is P raised to power R minus L plus 1. Just remember this thing. So if you want to see the explanation, you can find it on CP algorithms or just chat GPTs or anything. But make sure to remember both of these things, this thing and this thing. Just तोते की तरह रट लो भाई, ये चाहिए ही चाहिए. बट हमेशा जब भी ऐसा आता है तो ये स्टैंडर्ड थिंग है, मतलब until or unless you are not doing some chord forces like grandmaster or something or master something, these things will remain same. You can just copy paste them directly. So just remember this thing. Okay. So now let's see the final solution. So final solution, let's see the steps we will see, right? Not the code part here. So first thing is, right, pre-calcu pre-calculate forward hash. Second part is pre-calculate backward hash, right? We have two things, right? Third part, what? Pre-calculate what? Prefix sum. I will name it as, right, just simple hash, right? Hash of prefix, I say. This I'll say back hash of prefix. I will say prefix sum. Okay. See, I have all this, right? Then what do we do? Then we need a method to get, right. So we'll do it later. We'll see it, right? Then for, right, right, index equals to 0 to where? N. What we are going to do? Let's see what we are going to do. We have two cases here, right? Odd length palindrome. Second case, even length palindrome. Okay. So for the odd length palindrome, what we are going to do? Right, सबसे पहले first find the maximum length that is possible. So let's say, right, it's 1 2 1 4. If I'm this position, how much I can go in left? 1. How much I can go in right? 2. So max length equals to what? Right, let's say minimum of what? Current index minus what? N minus I, right? This, let's say 4. 4 minus I, 1, what? 3. 3 minus 1. This is my max length. Then what I have? Low equals to what? 0. High equals to what? Max length, right? We have this thing, right? Then the next is what? We apply the binary search, right? I say, right, while, what do I say? At low less than equals to high. If this happens, what we are going to do? We shall calculate our mid equals to what? Right? Low plus high. Just binary search, I guess you can apply, right? Then if is palindrome, right? Right? If this is my palindrome, I need to pass the left, right? This one, left end and right end. So let's say this is a left and right, and what it will be, right? It is mid minus what? Mid minus my current length, right? So it's, sorry, index, right? On which index I am minus what? Mid. So next is what? Index plus mid, right? These two. And if this is true, we update what? We go up. We check for higher length. We update our low to mid plus 1, else we do high equals to mid minus 1. Same here. Same here. Now, how will this is palindrome will look like, right? So I give it left, I give it right pointer, right? We need to match the hash for it. So one we have forward hash, one we have backward hash. So, right, what do I do? So I say, right, so forward hash, right? Forward hash value will be what? So what do we define it here, right? Hash prefix, right? Hash prefix of what? R plus 1 minus what? Hash prefix of what? The standard equation, right? L multiply what? So we also pre-calculate the power so that we don't take the extra log and time complexity. So we'll pre-compute it and say like power array of what? r minus l plus 1, right? What will be my backward? So for backward, L equals to what? N minus 1 minus L. R equals to what? So backward L, backward R. N minus 1 minus, sorry, this is R, this is L. So right, so backward L will be what? I say right, back has prefix of what? What I'm going to say it, right? So backward R plus 1, same, just right, has prefix. Oh, this is back has. Back has prefix of what? Backward L multiply what? Power array what? Right, backward R minus backward left plus 1. Okay. So if they match, right, return what? If they match. Forward equals to backward. Just return this thing. Okay. So now both of these what we are going to check, right? Our answer we are going to update, right? Max of what? Answer comma. Let's say for both of these we get length forward. We get length forward. You have to do this thing for both. Both odd even, right? Do separately. Answer comma what, right? Prefix sum, right? Prefix sum what, right? Let's say base length is some base length. Just say base length, right? Idx plus what? Base length plus 1 minus what? Prefix sum of what? Idx minus base length. And finally, what do we do? We return the answer. So this is solution, right? This solution. So time complexity is right. Pre-computing, right? Has pre-computing hash will be what? O of n. Prefix is what? O of n. Then we iterate over, right, each index and we'd apply binary search. O of n log n, right? This is final time complexity. Space complexity is again O of n. So yeah, this is it. So I mean, see, if you remember, right, Mancher's algorithm, it's best you apply it directly, but that is not a standard algorithm, right? Not everyone knows. I don't know it. It took me 3-4 hours to do this, but yeah, this is very standard and intuitive approach. We know rolling S is a standard algorithm. Then we know how to apply binary search. We know if there is a monotonicity, we need to apply binary search. So all these things we know. It's just that we have to apply these multiple things together. So yeah, that's it. Thank you. भाई लेट्स सी द कोड भाई मैंने पहले ही सोल्व कर लिया था क्योंकि इसको फिर बहुत टाइम लगता, वीडियो नहीं बनता भाई इतना बड़ा. So let's see the code part. We will start. We'll do it again step by step, right? This is for forward prep, right? For forward hash. Why this is for backward hash? Why this is for the same approach, right? Just how we understood is the right the whiteboard diagram. We see is the same way, right? Prefix sum, right? Pre-calculate powers. We write a hash function. What is our hash function look like? The same condition we did, right? Prefix of I is what? I into P plus the current cap. The same, nothing major, just small function, right? I hope you all guys know how to calculate power in log n. So we'll pre-calculate it. P is 31, M is modulo for larger numbers, right? Okay. Then we reverse the array. We calculate the prefix sum. Then we calculate the backward hash, right? Backward hash. Pre-calculate the powers. Pre-calculate the powers. What we do in pre-calculate powers? We push initially for power of I is what? Power of I into P until I am, right? Simple. Now this is the main part, right? We iterate over the loop for each index. We find what is the max odd length. I n minus I minus 1. We see in the whiteboard diagram. Then we apply the binary search here, right? Best length is 0, while low less than high. We check the is palindrome. What does is palindrome do? Same thing. Find the forward hash, find the backward hash, and just compare and return. Simple. We can do this in orphan time complexity because we already know the hash thing, right? So then we write if it's true, we increase our window. Best odd length, best odd right. Then same we update the answer. Similarly, now again we do for the even length. For even length, write this, for example, let's say it's 4 4, right? Then 4 will be 1 and next 4 will be 1. So we again check if its even length is greater than 0, right? So if it's 0, right, there is no, if it's 0, there's no, what, no string we have. If it's 1, then we have string. But for this odd length, we have a string if it's 0, right? We have one single character, current character as the current string. So then we apply the same thing and we return the answer. I'll just submit. I just submitted it a few minutes ago. Okay. So the time complexity is of n log n for the loop and the binary search. Yeah. Thank you.